Alright guys, so now we come to confidence interval chapter. Inference based on a single sample. So remember last time we talked about sampling distribution and we talked about point estimator. So a sample mean is a point estimator. A sample proportion is a point estimator. You use sample mean to estimate the population mean. You use sample proportion to estimate the population proportion. That's what we talked about last time, and we also discussed the distribution of these 2-point estimator. So right now, the next step after we got a point estimator, if you take a look at the title of this chapter, we are making inference based on a single sample, only one sample. So if we have one sample, we can have the sample mean and the sample proportion, right? And we use this two to make inference of this two. So the job of a point estimator is to estimate a point. So if I draw a number line here, here's 0. The point estimator is to estimate a point. Now, however, like I said before, this is guessing. We are just guess, right? This scientific guess. And a point is just, it may not be accurate enough, right? If you point a point, you're just saying it is either this or not this. But that's too strict. We want something more general. We want to relax our restrictions. So that's why we have a confidence interval. We say, okay, I have a point, and I can tell you that from here to here, these are also possible range for the population parameter. So you can see we are relaxing our restriction and we come up with a bigger range. And we can also say that we are 99% sure the population parameter will lie in this range. And we can also say we are 90% sure, less sure, that the population is in this range, a smaller range, right? The smaller the confidence level, the smaller the range will be. So that's about confidence interval. And one thing you need to know about confidence interval. Let me draw another number line here. One thing we need to know about confidence interval is that we have a single sample, and we have a sample mean. We construct a confidence interval from here to here, and we say we are 90% confident. And when we say this is a 90% confidence interval, what does this 90% mean? Does it mean that the probability of the population mean lies in the confidence interval is 90%? No, that's not. That's not what it means. The meaning of the 90% is that, take a look at this sentence. It's that we select a lot of sample. If you take a look at the title here, it's a single sample, right? We only have one sample. But the confidence interval means that if we select a lot of sample, not only one, but a lot, then the percentage of all the confidence intervals we construct will contain the target parameter the probability is 90%. So if we select tons of sample, 90% of them has the target parameter. That is what the confidence interval means. And I will show you why it is that in the following discussion. So let's move to how to construct this confidence interval. So in this chapter, we are only focusing on 3 types of confidence interval. The first one is confidence interval for a large sample, a very large sample. The second one is a confidence interval for a small sample, but a normal distribution sample. And the last one is confidence interval of a large sample, confidence interval for proportion, population proportion, or sample proportion. Right? The last one I said in the sampling distribution video why we choose a large sample, right? Because only the large sample can be approximated to normal distribution. And for this one, a small but normal sample. When we talk about central limiting theorem in the sampling distribution video, we said that the larger the sample size, the better approximation to the normal distribution you will get, right? So if you have a very small sample and the distribution of that sample is not normal distribution, then who knows what kind of distribution the sampling distribution is. So we have to add the constraint here. If you really want to construct a confidence interval for the sample mean, you must have a normal distribution for a small sample. And then for the first type, it's really easy to understand. If you have a large sample, no matter what kind of distribution of the population is, the sampling distribution is always normal. Okay, so let's take a look at this one. If you want to construct a confidence interval of 1 minus alpha percentage, if you want to have a confidence interval of 90%, then 1 minus alpha, then alpha is 10%. Then this is your interval. And you can find the alpha, half of alpha, and the z-score correspond to that alpha in the table here. And if you don't know the population standard deviation, pay attention, this is population standard deviation. You can use sample standard deviation S to estimate it. Right? You substitute the sigma here with S. That's when you don't know the population standard deviation. I said earlier in this video, I will show you more about what this sentence means here. So if you take a look at how we construct an interval, right? We want an interval we want an interval like this. And we want to know the probability of this, right? This is the probability of this. And if we take a further look, if we simplify this one, it is right? So what is this? And what is this? This is the sample mean we get based on a single sample, right? And what about this? The two sides here. If you recall the sampling distribution of sample mean, it's a normal distribution with mean equal to the population mean, and the standard deviation equals to the standard deviation divided by square root of n. Right? And the range here and here, it's this. Right? So our sample mean we get based on a simple sample could be anywhere from here to here. It could be here, it could be here, it could be here. And let me change the color and suppose it is here. And we construct a confidence interval. Use this. We construct a confidence interval. This is what we get. And suppose, let me use another color. We got a sample mean here. And we construct the interval here. You see, these two intervals, they all have the population mean. Right? But if we have a third x, maybe here, and we construct the interval, and this interval does not have the population mean. So basically it says that 90%, basically this means that 90% of the confidence interval we can construct from a lot of sample that contains the target parameter. So now you understand, and you can also see that everything we discussed about confidence interval is based on the sampling distribution of sample mean. It is based on a normal distribution with the mean equals to the population mean and the standard deviation equals this. So this is about confidence interval. And for confidence interval for small but normal sample, if we know the population standard deviation, then it's easy to construct. But if we don't know the standard deviation of population, you need to use the t-statistic. Just pay attention to the degree of freedom here and look up the value of t in the table. Then you can construct the interval. The last type is confidence interval for proportion of a large sample. And this is how you construct it. The rules are similar. Use the standard deviation of sampling distribution of sample proportion. And this is how you get the standard deviation. And if you don't know the population proportion, you can substitute it with the sample proportion, right? It is a good estimator of population proportion. You can substitute it with, but it will become less accurate. And always remember to check whether you are dealing with a large sample or not. If you are not dealing with a large sample, you cannot use the formula here to construct a confidence interval. And we will now discuss how to construct the confidence interval for population proportion of a small sample. We will not discuss that. Okay, so this is everything I want to say about confidence interval. So the most important point is that for confidence interval, the formula, it seems like it is based around the sample mean, a single sample mean. But if you transform the formula like I did here, it is still based on our sampling distribution, the population mean. It is still based on the graph here, this graph. And always remember this graph. It'll be also helpful to think in this way in the hypothesis testing chapter. And always remember, we are constructing a confidence interval based on a single sample, right? A single sample. However, the confidence level 90% or maybe 95% or 99%, it is based on a lot of samples. You select a lot of samples. So the formula here, this represents tons of samples. And if you construct a confidence interval of 90%, you can see if the sample mean of your sample lies within this range. What is this range? The area of this is 90%. If it lies within this range, then your confidence interval will contain the population mean. However, if your sample mean lies outside this range, here is 5%, here is another 5%. If it lies outside that range, then your confidence interval won't contain the population mean because the distance is larger, right? It can't reach the population mean. Try to understand confidence interval in this way. It will be helpful. And one more thing here I forgot to mention when we discussing. So when we are constructing confidence interval, you want your interval to be accurate, to be as much accurate as possible, right? And of course, you can say, I want a 99% confidence interval. Then you are 99% sure that your interval will contain this. It will contain a population mean. However, in that way, if you take a look at this, your z-score will be extremely large, and your confidence interval will also be extremely large. That is not good. So, in order to decrease the size of your confidence interval, the only thing we can do is increase the n here, increase your sample size. If you increase the n, the whole value of this part will decrease. Therefore, we can have a smaller confidence interval. And this also justified what we said before. The larger the sample size, the better result you will get, the better approximation to normal distribution you will get. Okay, so that's what I want to say about confidence interval. Bye bye for now.